Now see the tenth sum. Prove that A plus A transpose is symmetric and A minus A transpose is a skew symmetric matrix. So in the tenth sum, I have changed the numbers and took because we will need it in the next sum. Same type of sum we will see. So in 10 and next sum is you have to find a matrix as a sum of symmetric and a skew symmetric matrix. 10 sum very easy. In this way only you solved 10th first and second one. So so matrix is A 3 3 minus 1 minus 2 minus 2 1 and minus 4 minus 5 2. So we want to show that A plus A transpose is symmetric. So first A is given, find its A transpose, then find A plus A transpose. Write down A plus A transpose, add the corresponding elements. So see, here 1 is there, here also 1 is there, minus 5 minus 5 minus 4 minus 4. So A plus A transpose is a symmetric matrix. Now A minus A transpose we will find. We are having A also and A transpose also. First we have done the addition, now we will do the subtraction. So see, 3 minus 3 0, subtract it. 3 minus and minus 2 means plus 2, it becomes 5, minus 1 plus 4 is 3. In the same way subtract all the elements. Now see here the diagonal elements are 0 and non-diagonal elements here plus 5 minus 5, 3 minus 3, 6 minus 6. So the conditions for skew symmetric matrices are satisfied, that is diagonal elements are 0 and Aij is equal to minus Aji. So this A minus A transpose is a skew symmetric matrix. So any matrix A it is given, then these two conditions will be satisfied. When you do A plus A for any matrix A, means for A plus A transpose is symmetric and A minus A transpose is skew symmetric matrix. So these numbers I have changed, but you can complete in the same way. You can solve question number 10th, 1, first and second, where the A matrix is given. Now see the 11th one. In 11th one, now here that on the same matrix you have taken. Express each of the following matrix as the sum of symmetric and skew symmetric matrix. So now this is given only. See the sum, a square matrix can be expressed as sum of symmetric and skew symmetric matrix as follows. Means A is equal to, this is formula type only, A is equal to half. See what is A? A must be equal to half A plus A transpose, which is symmetric matrix, plus half into A minus A transpose. This you have to remember. How to write as how to write the matrix as a sum of symmetric and skew symmetric matrix. So this is this is symmetric and this is skew symmetric matrix. Now you have to prove it. Now first our matrix, this is our matrix A. Second sum from question number 11. Write its transpose. So how to write the transpose? Row as column and column as row. 3 minus 2 minus 4. 3 minus 2 minus 5 and minus 1 1 and 2. Now what we want here? A plus A transpose. Okay, so A plus A transpose is equal to these two matrices, add it. Add the corresponding element. 3 plus 3 6. 3 minus 2 1. So we got A plus A transpose. But here what we want? Half into A plus A transpose. So we will assume this as P. Let P is equal to half into A plus A transpose. So half and this matrix A plus A transpose as it is. Now multiply this half inside, that is 6 into half will be 3. This is 1 by 2. This is minus 5 by 2. This is also half. This is minus 4 by 2 is minus 2. Minus 4 by 2 is minus 2. This is minus 5 by 2. This is minus 4 by 2 is minus 2, and this is 2. Now see this matrix. See the elements, half, half, minus 5 by 2, minus 5 by 2, and minus 2, minus 2. So this is which type of matrix? So this P matrix we got as a P is a symmetric matrix. Now we will see the second term. See the second term. Second term is A half into A minus A transpose. So first we will write A minus A transpose. Now minus, subtract the corresponding elements. 3 minus 3 is 0. 3 minus minus 2 is 5. Minus 1 minus minus 4 is 3. In the same way, subtract the corresponding elements of A and A transpose. We will get this matrix. Now what we have to multiply it by half. So let Q is equal to half into A minus A transpose, that is half, and this matrix. Multiply this half inside. So 0 into half, half. This is 5 by 2, 3 by 2, minus 5 by 2, 0. 6 by 2 is 3, minus 3 by 2, minus 6 by 2 is minus 3, and this 0. Now see this matrix. The diagonal elements are 0, and see the non-diagonal elements. This is 5 by 2, then this is minus 5 by 2. This is 3 by 2, minus 3 by 2. 3, minus 3. So this is which type of matrix? It is a skew symmetric matrix. So P plus Q means what? P is a symmetric matrix and Q is skew symmetric matrix. So A is P plus Q. We have written A is equal to half this matrix plus this matrix. This matrix we have assumed P, and this is Q. So A is equal to P plus Q. P plus Q. So we have expressed the matrix as sum of symmetric and skew symmetric matrix. Next one, 12th one. Matrix A is given, matrix B is given. We have to verify A into B transpose is equal to B transpose into A transpose. Now see the LHS. See LHS. AB. First we have to find AB, means multiplication of A and B, and then find its transpose. So write down A matrix, B matrix. Then do its multiplication. So this is order 3 by 2 and this is 2 by 3. So this 2 and 2 is same. So the resulting matrix will be the order 3 by 3. Write down the order first. So the multiplication will be easy. So multiplication will be easy. Now see how to multiply. Row into column, row into column, and row into column. So first we will complete first row. This row will be completed, then only we will go to the second row. So when we start with this row, all the elements will come in first row. Okay, where after completing first row only we will go to the second row. So now see how to multiply. Row into column is there. So 2 into 0, 0, minus 1 into 2 is minus 2. 2 into 3, 6, minus 1 into minus 1 is plus 1. 2 into minus 4 is minus 8, minus 1 into 1 is minus 1. Now our first row's multiplication with all the columns is completed and we have written it in the first row. Now we will take the second row. Now first row is completed. Now go to the second row. 3 into 0, 0, minus 2 into 2 is minus 4. 3 into 3 is 9, minus 2 into minus 1 is 2. Now 3 into minus 4 is 12 and minus 2 into 1 is minus 2. This we have written in the second row. Now third row, first and second row is completed. We have written these two rows. Now our third row with all the columns. So 4 into 0 is 0 and 1 into 2 is 2. 4 into 3 is 12 and 1 into minus 1 is minus 1. 4 into minus 4 is 6 minus 16 and 1 into 1 is 1. Now do calculations, you will get this 3 by 3 matrix. Now for LHS we want its transpose. So find out its transpose. 2 minus 4 minus 2 will come the row. This second column will also become row and this third will also become row. Give number 1. Now see what is RHS. B transpose into A transpose. So first we will find B transpose. So B we know, find its transpose. A also we know, find its transpose. Now again we want its multiplication. So B transpose into A transpose. So B transpose I have written here, A transpose I have written here. Now we will multiply it. See, this is the order 3 by 2 and this is 2 by 3. So this 2 and 2 is same. So our new matrix will be of order 3 cross 3. So when you write first order, your sum multiplication will not go wrong. Now row, what I told, start with row. Row into column. Row into column. Row into column, and we will complete the first row with all the columns and we'll write it as a first row. So 0 into 2, 0, and 2 into minus 1 is minus 2. Then 0 into 3 is 0 and 2 into minus 2 is minus 4. 0 into 4 is 0 and this 2 into 1 is 2. Now first row is completed with all the columns, all the 3 columns. Now we will take the second row. 3 into 2 is 6 minus 1 into minus 1 is 1. 3 3s are 9 and minus 2 minus 1 is 2. 3 into 4 is 12 and minus 1 into 1 is minus 1. Now first two rows are completed. We will take third row. Minus 4 into 2 is minus 8. 1 into minus 1 is minus 1. Minus 4 into 3 is minus 12 and 1 into minus 2 is minus 2. Minus 4 into 4 is minus 16 and 1 into 1 is 1. Do calculation, you will get B transpose A transpose matrix. Now say RHS B AB transpose and this matrix, they both are same. So from 1 and 2, LHS is equal to RHS. Now in that second is AB transpose is equal to A transpose into B transpose. Now for this we will find first AB was there. Now BA, we will find BA. Multiplication of B and A. Write down B. First write down B, then write down A. This is of the this matrix order is 2 by 3 and this is 3 by 2. So this 3 and 3 is same. So new matrix will be order 2 by 2. Again the same way, row into column, row into column. So 0 into 2, 0, 3 into 3, 9, minus 4 into 4, 6, minus 16. Then again this row with this column. So 0 into minus 1, 0, 3 into 2, minus 6, minus 4 into 1, minus 4. So our first row is completed. Take second row. 2 into 2, 4, minus 1 into 3, minus 3, 1 into 4 is 4. Now this into this, so 2 in minus 2, minus 1 into minus 2 is plus 2, 1 into 1 is 1. Do calculation, you will get this matrix. Now we want its transpose. Write down its transpose. This is 1. Next, A transpose, RHS now we'll see. A transpose into B transpose. So A transpose we know, B transpose also we know you have to multiply it. So this is order 2 by 3 and this is 3 by 2. So this 3 and 3 is same. So new matrix we will get of order 2 by 2. In the same way multiply it. Row into column we will write here. Row into column, write it here. Row, second row, first column here, and second row, first column here. So this is our second matrix. So from 1 and 2, LHS is equal to RHS.